Okay, let's jump right in. I am absolutely thrilled to share this explainer with you today because we're setting the stage for a journey into one of the most staggering mega projects of the 21st century. We're talking about human engineering pushed to its absolute limits, battling the unforgiving oceans and completely revolutionizing global trade in the process. Today, we're tearing down the blueprints of the CMA-CGM Jacques Sade. It's a colossal, eco-friendly megaship that practically defies imagination. Get ready, because the sheer scale of what we're looking at today is going to blow your mind. To really wrap our heads around the scale we're dealing with, just consider this number for a second: 100,000 liters. Think about your car. When you start it up in the morning, it takes what? A tiny splash of fuel to get the engine turning. Well, this ship literally drinks 100,000 liters of fuel just to start up, and that's before it even begins moving across the ocean. That singular fact pretty much tells you everything you need to know about the absolute beast we're dealing with today. And that actually brings us to the core tension of this explainer. Building a machine this massive isn't just a tough engineering challenge, it's a logistical nightmare. So how exactly do 10,000 workers from all over the world come together to build not just one, but a fleet of 9 of these $200 million megaships in a mere 2-year window? Honestly, it sounds completely impossible. But as we'll see when we uncover the incredible engineering behind it, impossible is really just a starting point. All right, section 1, the 38,000 cargo ship problem. Okay, let's dive into this. To understand why this megaship even had to be built in the first place, we have to look at the invisible world of global trade. We live in the 21st century, yet 90% of everything we buy, literally everything, from the smallest sewing needle to the largest luxury vehicle, is transported by sea. If you pull up a flight radar right now, there are roughly 15 to 20,000 airplanes in the sky. But on the sea, at this very second, there are an astonishing 38,000 active cargo ships moving goods. Our entire modern world relies completely on the oceans to function. But here's the catch, and it's a big one. We've basically already built ships as wide as the Earth will allow. If we make them any larger, they physically won't fit through the world's major arteries, like the Suez and Panama canals. So the era of just building wider ships, that's over. The real race now isn't about physical size anymore. It's all about clean efficiency. And that is exactly why the French shipping company CMA-CGM decided to build the world's largest eco-friendly ship, completely ditching heavily polluting diesel for something entirely different. Section 2, a giant of the seas. So we know they can't make it much wider, but the physical dimensions of this vessel are still mind-boggling. Let's look at what a true giant looks like on paper. 70,000 tons. That is the empty weight of this ship without a single piece of cargo on board. To put that into perspective, that's the equivalent weight of 7 Eiffel Towers or 11,500 standing African elephants. It's taller than the Qutb Minar, and its 400-meter length is the exact same as taking 4 entire football fields and placing them end to end. And when you fill it up, it gets even crazier. This giant can carry 23,120 standard shipping containers at a single time. If you took all of those containers off the ship and lined them up end to end on a highway, they would form a continuous, unbroken wall of steel stretching for 150 kilometers. It's practically a moving, floating city. Moving on to section 3, building a steel mountain. So how do you actually construct a moving city, especially on a tight deadline? Well, the monumental task was handed over to a shipyard in Changxing, China. Now, this shipyard is essentially its own town, stretching 4 kilometers long, where 6,000 dedicated workers operate day and night, each fighting against an impossible construction deadline. Let me walk you through the insane rush of this project. Normally, one ship takes 18 months. They had to build 9 of them in 2 years. They kicked things off by cutting 12,660 steel sheets using a specialized laser beam operating at 18,000 degrees Celsius. That is literally 3 times hotter than the surface of the sun. It sliced through 880 kilometers of steel like a hot knife through butter. Then came 9 months just to build the fuel tank, followed by a year and a half of rapid assembly for the first ship, and finally 15 grueling days of sea trials. To actually meet this insane deadline, they built the ship in modular puzzle pieces called blocks. Some of these are the size of a room, others are as tall as a multi-story building, and come pre-fitted with pipes and wiring. The rear section alone was made of 5 blocks weighing 790 tons. That's the weight of 2 train engines. It required 2 giant cranes just to lift it. And here's the absolute craziest part. As they hoisted this massive steel block onto the hull, they had to strictly follow the 1 millimeter rule. A single millimeter of misalignment could literally ruin months of hard work. No pressure, right? And this brilliantly illustrates the sheer mind-numbing labor involved. 1,250 kilometers of welding. Once those blocks were perfectly in place, the meticulous and exhausting welding began. The total length of the weld seams on just this one single ship is so vast that if you laid it out in a straight line, it would stretch all the way from Karachi to Lahore. And every single seam had to be relentlessly checked, because out on the water, the merciless ocean waves absolutely do not forgive weak joints. Section 4. The Giant Thermos Challenge. Now, moving past the steel hull, how do you fuel a ship this massive without completely destroying the environment? Well, the answer instantly justifies that $200 million price tag. Traditional ships burn heavy oils and diesel, which are, frankly, massive polluters. But this ship, it's designed to run entirely on LNG, liquefied natural gas. The environmental win here is staggering. Compared to traditional fuel, LNG releases 99% less sulfur dioxide, 91% less overall particulate air pollution, and 20% less carbon dioxide. It is an absolutely massive step toward cleaning up global shipping. But of course, there's a catch. To store LNG as a liquid for a long voyage all the way from Asia to Europe, it has to be kept freezing cold, minus 61 degrees Celsius to be exact. If it warms up, it turns back into a gas, rapidly expands, and, well, it's game over. So they had to build the largest LNG fuel tank in history, an 18,000 cubic meter tank. It's big enough to fit 6 Olympic swimming pools inside, holding 20 million liters of fuel. And the inside is lined with a special 1.2 millimeter thin wavy steel membrane. This is literally technology used in space stations that shrinks and expands without breaking when that freezing fuel hits it. Because this tank has to be perfectly insulated and completely airtight, they had to test every single joint. And I absolutely love this detail. Look at how incredibly low-tech ingenuity solved a high-tech problem. To find leaks, workers applied simple soap and water to the joints. Then they placed a glass container over the joint and used a compressor to suck all the air out, creating a vacuum. If the joint was weak, outside air would rush in and they'd instantly see soap bubbles forming under the glass. It is a brilliantly simple way to ensure absolute perfection. Let's move into Section 5, powering the megaship. Now, what's really interesting about this next part is exactly what it takes to physically push a 70,000-ton steel mountain through the water once that clean fuel actually reaches the engine. Take a second to absorb these engine specs, because this is the largest natural gas engine ever built. It's 20 meters tall, that's a 6-story building. It weighs over 2,000 tons and cranks out a jaw-dropping 85,000 horsepower. It's got 12 pistons, each a full meter in diameter. The thing is so unbelievably huge that the maintenance staff can literally walk around inside of it. Just getting the engine's 220-ton crankshaft to the shipyard required a specialized remote-controlled platform with 140 wheels. All of that immense power transfers to a massive 92-ton, 10-meter-tall propeller at the back. But connecting the engine to the propeller via a massive shaft requires absolute millimeter perfection. Even the slightest bend will cause violent, destructive vibrations at high speeds. To prevent this, engineers perform a really delicate alignment test. They coat the shaft in a special blue dye, carefully insert it into the propeller, and then pull it right back out. The dye marks exactly where the metal touched. By studying those contact points, they can shave off tiny millimeters of metal until the fit is completely 100% flawless. Section 6, the ultimate sea trial. Okay, so the blocks are welded, the giant thermos is sealed tight, and the 6-story engine is perfectly aligned. But before this fully assembled ship hits the unforgiving ocean, it needs armor. The salty ocean and its rough waves will literally eat raw steel alive. Plus, a rough hull increases friction and wastes precious fuel. So they apply a special coating. It took 1 million liters of paint to cover 9,500 square meters of the ship. To give you a mental picture of that, the painted surface area of this ship is double the total size of Vatican City. Finally, after a year and a half of relentless, around-the-clock labor, the Jacques Saudet was ready for its 15-day sea trial. Now, this wasn't some leisurely cruise. It was a brutal stress test. They maxed out the engine speed, slammed on the emergency brakes, stress-tested the 360-degree smart camera navigation systems, and rigorously checked for any structural leaks. They even tested the deployment of its massive anchor. Just get this, one single link of this anchor chain weighs 300 kilograms. The entire chain weighs as much as 60 African elephants. And remarkably, after all that, the ship passed every single test with flying colors. So, the crucial point we should take away from all this is, they actually did it. The shipyard beat the clock, delivering not just one, but eventually 9 of these record-breaking, eco-friendly ships. This explainer isn't just about steel and gas. It's a testament to thousands of workers coming together and achieving the impossible. Which leaves us with a final thought to ponder today. If human ingenuity can seamlessly push mountains of steel across the world's oceans using clean fuel, what impossible boundary are we going to break next? Thank you so much for exploring this with me. Keep wondering, keep learning, and I'll see you in the next one.